This is section 8.3.2, which is on polynomial theorems. We're actually skipping the classwork just because it's meant to be done in groups. So we're just going to go ahead and take a look at these theorems. So if we have a, and we know that that's a zero of the polynomial p of x, then that automatically means x minus a is a factor, and this is according to the factor theorem. So for example, if we know that x equals 3 and x equals -2 are zeros of the polynomial, then we can safely say that the factors are x minus 3 and x plus 2. So remember, a factor goes into a polynomial evenly, which means if I were to take the polynomial and divide by the factor, the remainder would be 0. So another example, if I tell you that x equals 5 is a root of a polynomial, that means that x minus 5 is a factor, and that's the factor theorem. The next theorem is the fundamental theorem of algebra. What this states is a polynomial of degree n with real or complex coefficients has exactly n roots, which may be real or complex. So this is something that we've already been using. So for example, if we have a 5th degree polynomial, then it obviously will have 5 roots. And so it has a capacity to go through the x-axis 5 times, but it might not if it has imaginary roots. So again, it's just telling you the degree of the polynomial, tells you the number of roots. So a few examples, if I have a polynomial in standard form, and it's 3x squared plus something, so that's the first term, so we know it's a second degree polynomial, which means that it will have 2 roots. And in this case, they could be 2 real or they could be 2 imaginary. So the reason why it can't be 1 real and 1 imaginary is because imaginary numbers always come in pairs. Now looking at the next one, if we have -2x cubed, so that's a 3rd degree polynomial, which means it has 3 roots. So this one could have 3 real, or it could have 1 real and 2 imaginary. It cannot have 2 real and 1 imaginary. And lastly, we have 5x to the 4th. So this would have 4 roots. So the options are that it could have 4 real, it could have 4 imaginary, and lastly, it could have 2 real and 2 imaginary. So it can't have 1 real and 3 imaginary, or 3 imaginary and 1 real. So those are the only options. The next theorem is the integral zero theorem. What this states is for any polynomial with integral or integer coefficients, if an integer is a 0, remember 0 is another word for root or x-intercept of the polynomial, it must be a factor of the constant term. Okay, so let's look at an example. So if we have x squared plus 5x plus 6, that means the 0, which happens to be -2, also has to be a factor of the constant, which is 6. And we know that the factors of 6 could be plus or minus 1, 2, 3, or 6, and -2 is a factor of 6. So that means anytime you have a 0 of a polynomial, it will be a factor of the constant term. The next theorem is the remainder theorem. So for any number c, when a polynomial p of x is divided by x minus c, the remainder is p of c. So this one's a little bit easier to see when you actually do it. So for example, if I have x to the 4th minus x cubed plus 20x minus 48, and I divide by x minus 5, and when I do that, I get a remainder of 552. That means that p of 5 is 552. So it's kind of weird. So let's look at an example of that. So let's say I want you to find p of 3 for this polynomial. So obviously one option is that we could plug in 3 for the x. So it would be 2 times 3 cubed minus 3 times 3 squared plus 5 times 3 minus 1. The other option is that we could take that polynomial, divide by x minus 3, and whatever our remainder is will actually be the answer. So I'm going to choose to use synthetic division. So I take my coefficients, 2, -3, 5, -1. My multiplier is 3. And remember, I don't have to set it equal to 0 because it's already done for us. So you bring down the 2. 2 times 3 is 6. -3 plus 6 is 3. 3 times 3 is 9. 5 plus 9 is 14. And 14 times 3 is 42. -1 plus 42 is 41. So remember, that last term is a remainder. If we got 0, then that would mean that x minus 3 is a factor. So what this means is x minus 3 is not a factor, but it also means that p of 3 is equal to 41. So we evaluated the polynomial at 3 using synthetic division. All right. Our last theorem is the rational root theorem, which is going to be extremely important for the next section. So the rational root theorem helps us find the roots of a polynomial. So if I wanted you to find the roots of a quadratic, it would be very simple because we know how to solve a quadratic. So we can factor it, quadratic formula, complete the square, etc. But if I give you an x to the 5th degree polynomial and I want you to find all of the roots, it gets a little tricky. When I give you one root, it will at least help, but next section, you're going to be given no roots. So the rational root theorem helps narrow down so we have at least possible roots. So it states that the possible roots of a polynomial are the factors of the constant term divided by the factors of the leading coefficient. So if we're looking at this example, we have x to the 4th minus 3x cubed plus 7x squared minus 12x plus 18. So if I wanted you to find all the x-intercepts, the first step would be to find the possible roots. So the possible roots would be plus or minus the factors of the constant term, which is 18. So that would be 1, 2, 3, 6, 9, and 18. And we would divide by plus or minus the factors of the leading coefficient, which happens to be 1, so it doesn't affect this. So that means that those are all possible x-intercepts, and so I would then have to test them by plugging them in, and we're going to get to that the next section. The last thing of this section was sum and difference of cubes. So these are formulas that you might have remembered from last year or the year before, but we're just going to quickly review them. So they're stated above. And then if we are to factor this, we would say that a is equal to x and b is equal to 2. So the factors would be x plus 2, and this would be x squared minus 2x plus 4. So obviously we can get to that in other ways, but this is just a shortcut, so it makes it a bit easier, just like difference of squares. This one is a difference of cubes, so a equals x and b equals 3, and so this would be x minus 3 times x squared. This would be plus 3x and then plus 9. Okay, so that is everything about theorems for this section and also sum and difference of cubes.